Welcome to what should be a daily fluid mechanics video section, or approximately daily. And we're just going to be doing example problems from fluid mechanics. So here's an example problem for today. A fluid that occupies a volume of 24 liters weighs 225 newtons at a location where the gravitational acceleration is 9.8 meters per second squared. Determine the mass and the density of this fluid. Well, we should know that when something has a weight at a particular location, the weight is equal to the mass times g, which is the gravitational acceleration at that point. So we already know that the gravitational acceleration in this case is 9.8 meters per second squared. And what we need is the mass, but we also know what the weight is. So we have 225 newtons, and we should note over here that a newton is the same as a kilogram meter per second squared. This is going to be important. So the units are going to be important, in this problem. So we know that 225 newtons equals mass times 9.8 meters per second squared. And when I divide that, notice that when I divide by the meters per second squared here are going to go away in our newtons, and we're just going to be left with kilograms. So our mass is going to be equal to 225 divided by 9.8, which is approximately 23 kilograms. Okay, so this nice cancellation of these units here happens, and we're just left with kilograms. So that was the first part of this problem, but we have another part which asks the density of the fluid. So we should note the equation for density, which is rho. Usually we like to have it as rho, which is the mass per unit volume. And now we know what the mass is. However, we like to be sure that we have proper units here. So in this case we have liters, and we could just leave it and then make sure that our units of density are that way. So we could say that our rho is just equal to 23 divided by 24, and in this case this is going to be in kilograms per liter. However, lots of times we would like to keep the units consistent, so this is absolutely correct, by the way, as long as we have our units correctly stated. But let's use the units in terms of cubic meters. So a 1 liter is equal to 0.001 cubic meters. So we can restate the density as being 23 divided by 0.024 cubic meters, which we can find out real quick here, as being approximately, well, it's actually going to be and a third, so 958 1/3 kilograms per cubic meter. So 958 1/3, and I can just change this to exactly equal to, because that's what it is, kilograms per cubic meter. Both of these are correct. So it just depends on what you're trying to do with the quantity. Perhaps later you need to do something with the quantity that requires multiplication, and it's easier if it's in cubic meters because you have some kind of cubic meter quantity rather than liters, right? So just keep that in mind. That's all that I have for this video. I hope to see you again next time.